Welcome to Math Freaks. So today we are going to discuss this question of Ioqm challenges. This is the question number 2. So before discussing this, we will be discussing of two basic graphs, very elementary graph but very important. So one of them is the a to the power x graph. Okay, so there will be two graphs, one when a will be greater than 1 and one where a will be less than 1 but greater than 0. Okay, this is 1, this is 2. So for the one where a is greater than 1, we will have a graph something like this. Like this, and it will cut the y-axis at 0 comma 1. Now this is called as increasing graph. Now why increasing? Very simple. If you check the values of x, like for here say this is x1 and for here this is x2, so we can clearly say that x2 is greater than x1. Okay, and if you check the value of y for x1 and x2, say this is y1 and this is y2. So if you plot this in the y-axis, you will find that y2 is also greater than y1. So with an increase in x, our y is also increasing, hence it is known as increasing graph. Otherwise what you can do is, say for example a is equals to 2. Now what you will do is you can say y is equals to, as a function, 2 raised to the power x, right? 2 raised to the power x. Now if you see that if you increase x, then your y is also increasing. Say 1 is 2, 2 raised to the power 2 is 4. See, y is also increasing, so we will say that 2 raised to the power 2 has an increasing graph. Correct. Now let us move on to the second condition of a, that is 0, like greater than 0 but less than 1. For such condition it is also very simple. It's a decreasing graph, that is like this, and this is 0 comma 1 again. Now why this is a decreasing? Again very simple. If this is x-axis, this is y-axis, so again say x1 and x2. x2 is greater than x1, but if you look at the corresponding point on the y-axis for x1 and x2, you will find that y1 is greater than y2. y2 is less than y1. So as you can see, with an increase in the x, our y is decreasing. With an increase in the x, our y is decreasing. So this is known as decreasing graph. Now again, if you want to check this, you can check this for, say, y is equals to 1 by 2 raised to the power x. So see, if you increase x, this denominator will increase and finally our y will decrease. Correct. So this is known as decreasing graph. So to solve this question, this idea is enough, but I want to discuss another graph that might help you, that is log base a x. This also has two graphs, again greater than 1 and a greater than 0 but less than 1. For the one that is a greater than 1, we have a graph again that is increasing like this, and this cuts at 1 comma 0. Now okay, are you able to get that why this is 0 comma 1? Because here the x coordinate is 0, and if you put a raised to the power 0, then we get 1. So y is equals to 1 for x equals to 0. Similarly here also. Now this is known as increasing graph, again the same logic, all that. And for the second case, that is a less than 1 but greater than 0, we will have a decreasing graph which will look something like this. This is again 1 comma 0. This is a decreasing graph, and this is an increasing graph. Same logic you can use to explain these graphs, right? Now let us move on to our original question, that is this one. Now for this the equation given is 21 raised to the power x plus 22 raised to the power x plus 24 raised to the power x equals to 25 raised to the power x plus 26 raised to the power x. Okay, now I have an idea. What if we divide the whole equation by 25 raised to the power x? If we do so, what we are going to get is divide by 25 raised to the power x. We will get 21 by 25 raised to the power x plus 22 upon 25 raised to the power x plus 24 upon 25 raised to the power x equals to 1 raised to the power x plus 26 raised to the power by 25 raised to the power x. Now see, if I denote this with a1, a2, a3 and say a4 and a5, so we can conclude that a1 comma a2 comma a3 are less than 1 but greater than 0, and a4 comma a5 are greater than 1. So I hope that now you are able to catch the logic. So we can easily say that the graph of the LHS and RHS we can easily draw. These are not very complicated graph for which you need Desmos. These are very simple and elementary graphs. So for the LHS I am drawing, okay, LHS will be a decreasing graph, right? Let me write the equation. Plus 22 upon 25 okay, this is the equation. So this is LHS, this is RHS. So LHS is decreasing as the A1, A2 and A3 are, okay. So this will have a graph like this, and this will be now what, 0,3, obviously, because if you put the value of x as 0 you will find that the LHS is 3. So but the basic thing is that this is a decreasing graph. This is the main thing. Now if you look at the RHS, you can see this increasing. Why? Because the a is greater than 1, right? So it will be increasing, and where will it cut the y-axis? If you put x as 0 it will cut the y-axis at 2, right? So increasing, this will be, and this will be 0,2, right? Because if you put x as 0 we will get 2. So now we are asked to find the number of solutions, number of real solutions. Now if we are asked this, then where will we get a solution when the graph of the LHS and the RHS will intersect each other? Correct, will intersect each other, and the number of time they intersect each other is the answer for our number of solutions. Now observe these two graphs. What do you think? If they have to intersect, at how many points they can intersect? 1, right? Because they cannot intersect more than 1. Very simple observation. Even if you look at the graph very clearly, you will get that it cannot intersect more than 1 time. So simply our answer is 1 real solution. Correct? I hope that you understood this question. I don't know if you are going to solve this using the normal method, it will take you an extreme amount of time, while on the other hand if you solve it using the graph, see, within 2 minutes you can solve it, right? Very simple question. Thank you for watching. I hope you understood.